Equijoins, antijoins, and range joins. These types of joins are not effectively joins in themselves, or join types, but the way these joins perform and the way they behave are affected by the comparison conditions they use, namely equals, not equals, range searches with greater than, less than, or between, and also in and exist can be categorized in this section as well. Let's go through them. An equijoin sets an expression equal to an expression or asks if an expression is equal to an expression. This is very fast. Why? Because it finds an exact match on a single record. It goes straight into an index and finds one record with 4 discretes through a B tree, uses the row ID to go to the table, and finds the exact record. It's the fastest method of searching, and obviously the fastest method of joining. An anti-join is a negative. What it's saying is, I only want to find rows that are not equal to something. The result of this is it does not use indexes, and it does full table scan. If you've got small tables, no problem. If you've got a huge table with 1 million rows, you could be finding one record and reading 1 million rows. That's very bad for performance. Range joins. Greater than, less than, greater than or equal, less than or equal. It does use indexes, but it's not quite as fast as an equijoin because it does a range scan on the index. In other words, it doesn't do an exact hit in an index, it scans a section of the index. What's called a depth first traversal of a tree. Using in joins. In checks a values list. It's best not used with subqueries. It's most efficient with a string of literal values. In other words, you would check something and say, is it in a set 1, 2, 3, 4, 5, rather than doing a select statement from a table. You really need to avoid the use of the keyword not, because that will do exactly the same as the anti-join. It is effectively an anti-join. It avoids indexes and runs full table scans. Exist is more efficient than in certain circumstances. We'll get onto correlated subqueries when we get to the subqueries section. The reason why exists is more efficient are twofold. The first thing that exists does is when it finds what it wants, it stops searching. In doesn't. The second thing is that exists will allow you to match indexes in a subquery against an index from a calling query. So therefore it will use indexes in the calling query and the called query. So it's faster than in. Also, you want to avoid using not, the exists anti-join, because it avoids indexes and it runs full table scans.